Okay, let's dive into this. Have you ever looked at a mountain or a massive cityscape in a movie and wondered, how on earth do they map that? How do they build these stunningly realistic 3D worlds? Well, the answer is this really clever but also kind of simple idea at its core. Today, we're going to break down photogrammetry.
So, let's just start with a basic problem. Imagine you need to map the peak of a mountain, or maybe a huge, sprawling forest you can't even walk through. How do you do it? I mean, you can't exactly take a giant tape measure up there, right? This is the exact challenge that surveyors have been wrestling with for centuries.
And the solution, it turns out, is photogrammetry. It's really the science, and I'd say art, of getting solid, reliable information just from looking at pictures. At the end of the day, it's all about turning a simple photograph into a source of incredibly precise measurement. It's how we can survey the world without actually having to touch most of it.
Now, this isn't some one-size-fits-all technology. Nope. You can basically break photogrammetry down into two main flavors, and the difference is super simple. It's all about where you're standing when you take the picture.
So, on one hand, you've got what's called terrestrial photogrammetry. This is where you're taking photos from right here on the ground. Think of it like traditional surveying, but on steroids. But the method that really became a game changer is aerial photogrammetry. You guessed it, the photos are taken from the air. Ever since World War I, when airplanes really took off, this has pretty much become the go-to method for any large-scale mapping project.
Okay, so here's where it gets really cool. How in the world do we get rich three-dimensional information from a bunch of flat 2D pictures? This is the secret sauce, and believe it or not, the answer is inspired by something you are using this very second.
It's called binocular vision. It's the simple fact that you have two eyes. Right now, each one of your eyes is seeing the world from a slightly different angle. You can try it. Hold your finger out in front of you. Close your left eye, then your right eye. See how your finger seems to jump back and forth? That little jump, that's the whole key. Your brain is basically an incredible supercomputer. It takes those two slightly different images, one from your left eye, one from your right, and it instantly stitches them together into a single, seamless, three-dimensional view. That's how you perceive depth. It's how you know if something's close or far away.
And of course, there's a fancy scientific name for this, stereoscopy. It's the formal term for this whole process of seeing in 3D, and it all hinges on having that normal two-eyed binocular vision.
So, we just steal that exact same idea for photogrammetry. We basically give a single camera lens the power of two eyes, just by moving it. If we take pictures of the same spot from different locations, we've effectively created a left eye and a right eye view.
Now, in aerial photogrammetry, these different views are called stereo pairs. They're just adjacent photos of the same area taken from slightly different points as the airplane flies along. These overlapping pictures, they're the absolute essential building blocks for creating that 3D magic. All right, so we've got the principle down, but what does it look like in practice? How do you actually go from a plane buzzing in the sky to a finished, usable map? Well, it's a very organized four-step process. First up, you have the flying itself, and that has to be incredibly precise. Second, obviously, is the photography. Third is something called ground control, which is where you survey a few known points on the ground so you can lock your photos into the real world. And finally, you get to the compilation or mapping phase. That's where all the data gets crunched into the final product. Okay, as the plane is flying its path, it's just snapping picture after picture. But there is one rule that is absolutely crucial here. Each photo has to overlap the one before it by a minimum of 60%. And that number is not random at all. It is the secret to making this entire system work.
So why 60%? I mean, that sounds like a lot of overlap, right? Well, it guarantees two things. First, it makes sure there are absolutely no gaps, that no bit of the ground gets missed. And second, and this is the big one, it makes sure every single point on the ground gets photographed at least twice. And that, right there, gives us the stereoscopic pairs we need for that incredible 3D stereoscopic viewing. So, this gives you a little taste of the kind of raw data you get from this process. For any 2 points, let's call them A and B on the ground, we can pull their coordinates right from the photo, and we know their elevation. With that information, and some pretty clever math, engineers can turn pixels on a screen into a precise real-world measurement, like the exact horizontal distance between those two spots.
Okay, so this is clearly an amazing tool for just making maps. But its uses go far, far beyond that. The applications are actually incredibly diverse, and they impact way more of our lives than you might think.
I mean, think about it. It's absolutely essential for mapping rugged, mountainous countries where ground surveys would be just about impossible. Archaeologists can use it to create a perfect 3D model of a dig site without ever touching a single thing. Foresters can check on the health of an entire national park, literally tree by tree, all from the sky. And it's a critical tool in fields you might not expect. Everything from military intelligence to helping police reconstruct really complex accident scenes with pinpoint accuracy.
And this quote really hits the nail on the head when it comes to engineering. For any big infrastructure project, planning a new highway or railway, a massive power line, photogrammetry is the go-to method for that first survey. It's fast, it's accurate, and it lets you cover huge areas super efficiently.
So think about where we are now. We've gone from these giant cameras on airplanes to incredibly high-res sensors on small, nimble drones that anyone can fly. The core principles of photogrammetry are exactly the same, but who can use it is just exploding. It really makes you wonder, with this power to measure literally anything from a picture, what's the next frontier we're going to explore? What's the next thing we'll map?